So today we will do some more problem on basically time dependent perturbation, mainly transition probability. So uh, let us go for one very nice problem about which kind of transition are allowed or not. So it's a very interesting one. Let's go for this problem. So I have potential. This potential is equal to 0, and let's say x is between minus a by 2 to plus a by 2. And initially particle is in ground state. Particle is in ground state. Okay, so this is the initial condition that my particle is in ground state, and there are perturbation. The system is perturbed with let's say some potential, and that will be V naught delta x. This is my perturbation. Okay, so some potential V naught delta x. The question is very tricky. Which find the allowed transition. Find the allowed transition. So you have to write the rule of transition in general, but I have given that, okay, my particle is initially ground state. So from the ground state, in which state it can go? It can go to first state, second excited state, to third. What are the basic thing where it can go? Okay, so we have to just go for formula of transition probability. So what is formula of transition probability in this case? This is constant potential. Okay, not constant potential actually. This is not a time dependent potential. This is just a space dependent potential delta x. So this potential is something like this. So this is my actual system. This will be minus a by 2 to plus a by 2, and at x is equal to 0, we have some Dirac delta potential. So if we are using this potential, then which type of transition can be allowed? So if you remember our this solving of Schrodinger wave equation for this system, what are the possible allowed thing? What are the possible wave function? You have two type of possible wave function, isn't it? So first possible wave function is we have root under 2 by a cos n pi x upon a, isn't it? Where n is equal to 1, 3, 5 and so on. And we have 2 by a sine n pi x upon a, where n is equal to 2, 4, 6 and so on. So we know this particular state. And now if I want to go for the transition probability from, let's say, ground state means n is equal to 1, to any another state, then what are the formula basically? The formula is basically I upon h cut, and we have to go for matrix that will be phi n hp phi 1, and I can take it mod square, and or you can just go for this thing, and we have integration 0 to t e to the power I omega naught t dt, and we have to go for mod square. Okay, but when it is a constant part, this is just a special part. What will be the final result? Final result yaad hai aapko? What is this? This will be phi n hp phi 1 mod square, and here we have to go for sine square omega naught t upon 2, and here h cut omega naught by 2 whole square. This is the main thing, isn't it? And this mod square is there. Are you getting my point? If we are going to calculate this thing, then this is the main thing. Now, which transition is allowed dependent on this particular integration? And now look at here, how many integration we can do something like this. So we have to just talk about what are the allowed quantum number if my particle is in ground state. And we can also talk about in general also. So let us go for this particular thing. If my particle is in ground state and if n will be even, then is that this will survive? If n is even, then what is this particular integration? This particular integration is basically, if you can see it this particular integration, this one is basically we have phi n star delta x phi 1 dx, isn't it? And this particular integration will survive only when, if this function will be sine, then this will be not survive, isn't it? Because sine 0 is what? 0. Are you getting my point?
Yes, sir.
So this function will only survive if this function is what? Cos function.
Yes, sir.
Because this is cos function. This is 100% cos function. I am 100% sure that this is cos function. So this will be, so I can write phi n star delta x, and this will be root 2 upon a cos pi x upon a dx. So I know this function. Now I have to choose this function. And obviously n is equal to 2 is available for you, that will be survive for this equation? No. Because if n is equal to 2, there is sine function, and sine for the delta x is equal to what? 0. Yes?
Yes, sir.
Yes. So then if n is equal to 3, then it will survive, isn't it?
Yes, sir.
Because it will be cos function and it will give you just 2 by a as your integration. Then n is equal to 4 is not going to survive. Then n is equal to 5, yes, it is going to survive. So what can be the transition? What can be the possible transition? The possible transition is n is equal to 1 to n is equal to 3. You can go n is equal to 1 to n is equal to 5, isn't it? Or in general, if you want to generalize the thing, then which kind of allowed quantum number are there? Which kind of allowed quantum number are there? Suppose I am just giving you n is equal to even to n odd. Is that it is possible?
No, sir.
No, it is not possible. Second, n even, n odd. Is that possible?
No, sir.
Huh? It is also not possible because one term will be sine term, one term will be cos term. Third option, n is odd and another n is odd. Is that possible?
Yes, sir. Possible.
Yes, this is possible. So this kind of problem can come into your examination, isn't it? And last is even to even. So there are very nice 4 options. N even to n even. Yes, this will also not going to survive, isn't it? So you can see all the transition, whatever you have learned earlier are outcome of this type of calculation. Okay, some calculation are very tough, so we are not doing it. But if you ask me theoretically, then all kind of this transition are outcome of basically this transition probability, and you have what is your perturbation, which type of potential you are using, and you can easily say, okay, this is my possible transition. Okay, so I think you people are going to understand what is going to, and what will be this value. This value is nothing but 2 upon a v naught, है ना? So you will put this value is 2 upon a V naught square, and omega naught, you know that so there are n number of omega naught. If you are going 1 to 3, different omega naught. If you are going to 1 to 5, that is different omega naught. So they can be also ask you that what are the possible omega naught, isn't it?
Yes, sir.
They can also ask you what are the possible omega naught. What are the possible omega naught? The possible omega naught is E3 minus E1 h cut. Another omega naught is E5 minus E1 upon h cut, and so on. You can have all possible omega naught. So you have n number of transition can be possible if you are giving this Dirac delta as your perturbation term. So this is one of the wonderful problem. Okay. So let us go for one more problem. Next problem की तरफ चलते हैं. यहाँ तक clear है ना, everyone?
Yes, sir.
Yes, sir.
Okay. Okay, so let us go for next problem. Just a minute. Okay, so let us go for this problem. If particle in box as potential as Vx is given by 0 if x is between 0 to a is perturbed with potential V naught e to the power minus t upon tau, V naught e to the power minus t upon tau, where x is between 0 to a by 2 and t is between 0 to, let's say, some capital time tau. T is between 0 to some capital time tau. So we have to go for this one. Obviously, this is function of time. This is not a sinusoidal in nature, neither it is a constant in sense of time. Obviously, a spatial part is there as well as your temporal part is there. So what you have to do, you have to just calculate all the spatial part as well as temporal part. So you have to go for the first, you have to go for the basic definition of transition probability. So what we have to do, we have to calculate transition probability from ground state to first excited state. Ground state to first excited state. So what will be my transition probability? So my transition probability is basically P12 is equal to minus I upon h cut, and we have this particular thing phi 2 HP phi 1, and we have, hence this is function of time, so it will be inside the integration, and we have basically e to the power I omega naught t dt 0 to some capital time t, and we have to go for mod square. So this is our transition probability from 1 to 2. So let us try to calculate this one. So obviously this one has two part. One is a spatial part, another is temporal part. So we will take a spatial part together and temporal part together. So we have to do this integration. So this will be minus I upon h cut. One will be the spatial part, 0 to a by 2. So this will be 2 by a sine pi x upon a and sine 2 pi x upon a. V naught will come outside this integration. And there is another integration. And this integration is 0 to capital T. And this will be e to the power minus t upon tau and e to the power I omega naught t dt. Okay. And we have to take the mod of this, mod square of this particular integration. Isn't it? So you have to calculate each and everything. By the way, we have calculated already this one thing. What will be this value?
4 by 3 pi.
This value is 4 upon 3 pi by 3 pi, isn't it? This value is 4 upon 3 pi. So if we will go for this one, then obviously V naught square h cut square, and that will be 16 upon 9 pi square. If you are going to calculate this one, we have calculated it lot of time. So this is the thing. And now we have to calculate this particular integration. So if we are going to calculate this particular integration, 0 to capital T, e to the power minus t upon tau, e to the power I omega naught t dt mod square. We have to go for this one. So what will be this integration? So if you will go for this integration, then this integration is V naught square h cut square 16 upon 9 pi square. And this integration is, I can take minus t common, and you have 1 upon tau minus I omega naught dt. Okay. And we can go for 0 to capital T. So what will be this particular value? So this particular value is, I think this value is, you will have V naught square upon h cut square 16 upon 9 pi square, and this value is e to the power minus capital T 1 upon tau minus I omega naught minus 1, because this is 0 to t is there, and we have here 1 upon tau minus I omega naught mod square, and this will be also mod square, isn't it? Are you people comfortable?
Yes.
And what will be mod square of this one? What will be mod square of this one? 1 upon tau square plus omega naught square, isn't it?
Yes, sir.
So this will be equivalent to V naught square upon h cut square 16 upon 9 pi square, and I can take this one as same thing, minus capital T 1 upon tau minus I omega naught and minus 1 mod square, but this will be 1 upon tau square plus omega naught square. Now, anyone can ask you in the exam, what will happen when t tends to infinity? What will happen when t tends to infinity? This whole term will be 1. What will happen t tends to infinity? Sorry, this term will be 0. This term will be 0, and this term will survive here. So this will be 1, and you can have, when t tends to infinity, you can have something like this: v naught upon h cat square 16 upon 9 pi square 1 upon tau square plus omega naught minus 1, isn't it? This will be the value when t tends to infinity. So this type of question can come into your exam, and you have to prepare for this thing. Okay, so let us go for next one. ज़्यादा क्लियर है ना?
Yes, sir.
Yes, sir.
सो ओनली इंटीग्रेशन करना है, बट कितना इंटेलिजेंटली आप कर पाते हो, दैट इज मोस्ट इंपॉर्टेंट थिंग. ओके, चलो. सो वन डायमेंशनल हार्मोनिक ऑसिलेटर, डायमेंशनल हार्मोनिक ऑसिलेटर with angular frequency omega is perturbed with potential x square e to the power minus t upon tau, where x is between minus infinity to plus infinity and t is between 0 to infinity. Suppose this kind of situation is there. T is between 0 to infinity. So first question, find the transition probability from ground state to first excited state. Find the transition probability from ground state to second excited state. Okay. So we have to just go for this. Okay. So first we have to calculate omega naught. What is omega naught for first case? What is omega naught?
Omega.
The omega naught is 3 by 2 h cut omega minus half h cut omega by h cut. So omega naught is omega in first case. So omega naught is omega. Okay. And what is my x square? X square operator. So again we have to go for this formula. Minus I upon h cut. We have to go for basically, so this can be separable. So I can go for phi 0 x square phi 1 and integration 0 to infinity e to the power minus t upon tau e to the power I omega t dt. Isn't it? We have to go for this integration and we have to take the mod square. So obviously, now for what is x square? What is x square operator here? The x square operator is something x naught square into a square plus a dagger square plus 2n plus 1. Isn't it?
Yes, sir.
Okay. So now, if it will go to 0 to 1, is that this will be survive? This will survive?
No.
No. It will not survive, because if it will, a square will operate on this, then this will be 0. A dagger square will operate on this, then this will go to third state, isn't it?
Yes, sir.
This will go to what? Third state. So this is not going to survive. And this will remain at the same state. So again, this will again 0. So this transition is not allowed for this particular potential. So there is, this transition is not allowed. Let us go for this transition. Is that this transition is allowed or not? क्या ये allowed होगा? या नहीं होगा?
होगा सर,
होगा।
अलाउड।
किसके लिए अलाउड होगा? दिस वन
ये
here
शक्ल
2
है।
it will bring it at the ground level. So let us try to go for this one. So probability 0 to 2 is allowed. Here we have, so when we will go for this particular equation, then what you will get? You will get mod square minus I upon h cat. This value is phi naught a square plus a Dirac square plus 2n plus 1 phi 2. And we have 0 to infinity e to the power minus t upon tau e to the power I omega naught t dt mod square. So now which one is going to survive here? All among all three? Only this one is going to survive here, isn't it? Because a square
Yes.
will operate on phi 2, it will give you phi 0 with some coefficient root 2, isn't it? Root 2, root 1, and you will get phi 0. All other will be 0. So only one term is going to survive here. And what will be omega here? What will be omega naught here? The omega naught is basically 5 by 2 minus h cut omega by 2. So this is 2 omega naught. Sorry, 2 omega. Omega naught is 2 omega. So you have to always keep in mind that different transition have different value of omega naught. So let us go for this particular calculation. So
सर
हाँ बोलो.
सर इसमें जो हम लोग ट्रांजिशन प्रोबेबिलिटी के लिए VFI लिखते हैं तो
Sorry?
उसमें जो इनिशियल इनिशियल स्टेट रहता है वो केट में आता है ना, VFI वाला जो मैट्रिक्स एलिमेंट हम लिखते हैं.
ओके ओके
Phi
ये
2x
फाइव टू
square
फाइव
phi naught
जीरो
होना
एक ही
चाहिए
बात
ना?
होगा, कोई खास अंतर नहीं होगा बिकॉज मॉड स्क्वायर इज देयर. ओके यू कैन पुट ओके 0 to 2 yes 5250 yes you can write 5250. So you can put 52 here and 50 here. So what will happen? A square will survive, that will give you same thing, isn't it?
Yes sir.
अगर
Value same
न्यूमेरिकल
है।
वैल्यू देखो तो सेम आएगा. यस यू आर 100% करेक्ट अकॉर्डिंग टू फॉर्मुलेशन. दिस इज 5250. सो यस दिस इज 5250. मैंने उल्टा कर दिया, मैंने कर दिया 2 से 0 का ट्रांजिशन प्रोबेबिलिटी. बट you will understand that the same probability between 0 to 2 and 2 to 0 have more or less same probability, isn't it?
Yes.
Only what will happen, one will absorb the energy, another will release the energy. That is the only thing. But that in term of probability, both are the same thing. So let us go for this integration. Yes, you are 100% correct theoretically. So this will survive. Okay, a Dirac square will operate on this one. So what I will get, and x naught is also there. So some x naught, and what is value of x naught? X naught is basically h cut upon 2m omega. Okay,
X naught square होगा sir.
I am taking mod square here. Okay, this is what x naught square. Yes, this is x naught square. So this value is there. So you will take the mod square, then this will be 4, na? Okay.
Yes sir.
Yes. So let us try to go for this. What we will get? We will get basically x naught to the power 4 h cut square, and here inside we will get root 2 whole square because there is mod square. And what about this one? This one is 1 upon, if you will go for this integration, this will be 1 upon tau square plus omega naught square. So this will be probability from 0 to transition probability from 0 to 2. Okay, are you people comfortable?
Yes sir.
है ना? So this is the thing you can easily calculate. This is very simple calculation. They will, if they will give this type problem, they will always give you simple calculation. But thing is that you have to set the each and everything in a very nice way. Okay. So let us go for the exam problem, है ना? Exam problem में क्या आया था? So can you please tell
Sir?
me? हाँ बताओ.
सर ये x naught में भी ओमेगा नॉट होगा ना सर, रूट अंडर h.
बिल्कुल 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 x naught में omega naught नहीं होगा. That will be from the original Hamiltonian.
Oh, yes, sir. Okay, got it.
That is from the original Hamiltonian. This is your x naught. This is well defined. Okay.
Yes.
And here is omega naught में 2 omega आएगा. Okay.
Yes, sir.
So you have to, so you can write something like this. This will be h cut upon 2m omega whole square upon h cut square 2, and here is tau square plus 2 omega whole, sorry, this will be 4 omega square. Okay. 1 upon tau square plus 4 omega square. Are you getting my point?
Yes, sir.
So this is from the original Hamiltonian. The operators are from the original Hamiltonian. Okay. You are
Yes,
not
sir.
changing the operator. X is always X. Okay. What is my X operator? This X operator is root under h cut upon 2m omega a plus a dagger. This is my X operator. Are you getting my point?
Yes, sir.
And this is from the this potential half m omega square x square. And this omega naught are due to transition. This frequency are coming due to transition, from which state you are going to take the transition. So this is very important thing. Okay, so let us go for our test problem, है ना, जो अभी बता रहे थे. It's very simple, nothing to do. You have to just go for integration. I will just suggest how to do this thing. Can you please tell me what is the question? Just, or I can take from my desktop also.
Sir, time dependent electric field defined as above.
हाँ,
right?
एक मिनट में बता रहा हूँ. I think just a minute. So it does, this question is there, that one dimensional harmonic oscillator has electric field ET as a exponential minus t square by tau square. Okay, this is the problem.
Yes, sir.
Huh? And you will go t tends to infinity. Okay, t tends to infinity. So you have to just talk about the the transition probability, how the transition probability is basically in a proportionality term. You have to give the answer in a proportionality term. So there is not any problem. Listen, what is my main thing? The transition probability, and this is from which state to which state? They are not from ground state to first state. So these are giving ground to first excited state. So there is not any problem. We have to go for minus I upon h cat. We have to go for h naught hp, sorry, phi 1 hp phi 0, and exponential minus t square upon tau square e to the power I omega naught t dt. That is the thing. Okay, and we have to take the mod square. Okay, don't worry about this one, because you have to ask, you have to give the answer in term of proportionality. So I can assume this it will give some positive value, and that will be some constant. So just leave this part. Are you getting my point? You can just write this thing as V10 mod square h cat square, And now what you have to do? You have to just go for 0 to infinity, and you will go minus t square to tau square e to the power I omega naught t dt. And what is omega naught? Omega naught is equal to 3 by 2 h cut omega minus 1 by 2 h cut omega by h cut. So this will be omega. So ultimately I have to do this integration. So how you will do this integration? This is the main thing, isn't it? So what you will do,
Yes,
you will
sir.
just try to make it perfect square. So when you will make it perfect square, the time part will be inside your calculation, okay, inside your integration. And what you will do, you will just go for the rest of the term. Are you getting my point? How you will solve it? Let us try to solve it. Don't worry. Let us try to solve it in a very nice way. So only we have to do this integration. Don't worry. And we have solved this type of integration actually. So this probability P10 is proportional to actually this integration mod square. So this will be proportional to 0 to infinity e to the power minus t square tau square e to the power I omega t dt mod square. Okay. This is in a proportionality term. I take all the other term as a proportional term. So you will just go for 0 to infinity. You can take minus t square as a common, or you can use 1 upon tau square, and sorry, you can write something like this. You can write t square tau square plus I omega t dt, and you can make it perfect square. So how you will make it perfect square? So you can just take 0 to infinity e to the power minus 1 upon tau square, you can take common. This will be t square, minus sign is there, so this will be minus I omega t. So 1 upon tau square is common. So what will happen? Tau square is there, na? Yes?
Yes, sir.
So I can put from my side, that will be I omega tau square. I omega tau square. And this will be, I will just go for 2 here and 2 here. Okay. So that 2I omega kind of thing will be there. So 2I omega tau square. So then we have 2 also. And we can have minus I omega tau square upon 2 whole square dt. Can I write this thing?
Yes, sir.
Okay. So what you can do? You can just go for integration 0 to infinity e to the power 1 upon tau square. This will be t minus I omega tau square by 2 whole square. This one. And this term is what? Minus plus. And this tau square is also there. And this is constant term. So you can take it outside. Isn't it?
Yes, sir.
You can take it outside. So if you will take this term as a outside, then what you will get? You will get minus omega square tau square, because 1 tau square will be gone, by 4. Isn't it? And you have to take the mod square. So this will give you some value. Okay, some constant value. And what will be this value? If you will take the mod square, then you have P10 is proportional to e to the power omega square tau square by 2. So this will be answer, isn't it? Are you getting the point? Hello.
Yes, sir.
यही क्वेश्चन था ना?
Yes, sir.
So where is the confusion?
सर कॉन्फ्यूजन सर सर मैंने सोचा था सर ये हार्मोनिक ऑसिलेटर है,
हम्म
तो सर मतलब वहाँ पे ऑप्शन 0 भी था, तो मैंने सोचा था कि सर ये जो क्वार्टर टर्म है वहाँ पे तो सर एक्स वाला कोई टर्म है ही नहीं, मतलब एनिमेशन क्रिएशन, इसलिए मैं 0 सोच रहा था।
आप 0 सोच रहे थे, क्यों सोच रहे थे 0?
सर ये 5-1 मतलब एक्स वाला जो होता है ना,
नहीं
एक्स
नहीं,
इक्वल टू
सॉरी,
एक्स
दिस इज इलेक्ट्रिक फील्ड ना. सो इफ दिस इज इलेक्ट्रिक फील्ड, देन you have potential q e naught x. So this will survive. Are you getting my point?
यस सर।
If it is electric field, what is your potential? Your potential is q e naught x. Are you getting my point? Because
Yes,
charge
sir.
is there. Look at in the problem.
यस सर, चार्ज
है ना? So you have basically q e naught x is there. If x is there, then you can write q e naught a plus a dagger. Okay? So this will be always there. So obviously first order transition, the 0 to 1 transition is allowed, but I am not calculating it because my question is given such that you have to give the answer in term of proportionality.
यस सर।
Okay, this is electric field, this is not potential. Okay, the potential, the electric field is given in this term, E is equal to a e to the power minus t square upon tau square. This is electric field. So what is your potential? You have to write, you have to go for some charge. Let's say that charge may be unit charge, q u naught a into x. So x will be there. So transition between 0 to 1 is always allowed for this particular electric field. It is different thing that this electric field is decaying in nature, that is in Gaussian in nature. Okay, so why they
Yes, sir.
have, so why they have given the charge particle q? Are you getting my point?
Yes, sir.
Such that you can find the actual potential. So a lot of people are just neglecting this particular effect of this one, and so why they are just giving, okay, there is constant potential, so this potential is equal to what? 0. No, this is not constant potential, this is function of x actually. Okay, but we are not using it in our calculation. Why? Because we have to give the answer in term of proportionality. If they will ask in the complete answer, then obviously we have to solve each and every point. And you know what will be this value? If we will solve this thing, then this value is q e naught, and what will be this? This value is h cut upon 2m omega. That's it, isn't it?
Yes, sir. Yes.
ये तो कर चुके हैं, ऐसा प्रॉब्लम तो कर चुका है. So
Yes,
what you have
sir.
to do, you have to very much focused on a problem. What are they are asking in a problem? They are not giving you potential, they are giving you electric field. So if they are giving you electric field, Hamiltonian, in the Hamiltonian, which term will come? Electric field will not come. The energy due to that electric field will come. That is potential due to that electric field will come. Are you getting my point?
Yes, sir.
Okay. So why 0 is not your answer? Okay. So okay, so I will stop here.